Hello, I am Kay from Sundance DSP, and in this video I will be explaining what PARS can do to help you reduce the development time for your project. For software installation guide, please see the PARS software installation guide video. In this video, we assume that the hardware and all the necessary software have already been installed. It is also assumed that PARS get_high_m file is appropriately updated to represent the hardware being used. Here we start with the simplest example, which is to develop a filter bank application targeting a single TI DSP.
Two variations of the demo. One task on one DSP and 4 tasks on one DSP. In this demo, we will concern ourselves with the first version. For viewing the 4 tasks on one DSP and more complex applications using multi-DSP and multi-FPGA, refer to the next demos on the list. Okay, let's begin. Here we see a picture of the hardware being used. It consists of an SMT 310Q PCI carrier card and an SMT 395 VP30 DSP FPGA module and some other modules, but we're only concerned with the first module in slot 0. Note that there are some FMS cables in the back, which are used to add connectivity between different modules above and beyond what the carrier card provides. Here is a block diagram of the hardware. The block diagram shows how the modules are connected to each other through the COM ports and Sundance Digital Bus, but for this demo we are only using the first module marked as SMT 395. Note that the last slot on the carrier card is empty and can be used for adding another module later. The filter bank demo works like this. A pre-recorded audio file is read from the host and transferred to the application running on the DSP. Some computation, filtering, takes place and then the resulting audio file is sent back to the host and played via the speaker. To save time, the Simulink model was generated and it is assumed that users are familiar with Simulink. After starting MATLAB, change the directory to where the model filter bank MDL is stored. Open the model in Simulink. You can now see the model in its various blocks. Note that instead of using block from WAV file, one could use a microphone input block from Simulink. The model shows that the input is fed through 3 filters before combining the results with each other, before passing it to speaker device. Now, let's simulate this model in Simulink to make sure it works well.
The discrete Fourier transform of a real-valued signal is conjugate symmetric.
After you have heard the audio clip, stop the simulation and close the Simulink window. Invoke PARS by typing PARS in MATLAB command window. PARS dialog window should now appear. The first step is to go to Tools, PARS Options, and select the hardware description which matches the hardware. FPGA code generation requires the user to select HDL coder or system generator. As this demo does not use an FPGA, the option Automatic is selected. The options selected are now reflected in the PARS window. Now, go to File and open the filter bank model. Note that PARS always makes a copy of the model in a folder underneath where the original model is kept, so that the original model stays intact. You can clearly see in MATLAB that now we are pointing to a new folder that PARS has created and placed a working copy of the original model. As we were only interested to have one task on the DSP, we are going to select all of the blocks except the ones which are going to be running on the host. At this stage, we ask PARS to create a subsystem for the blocks we have selected. As a shortcut, you could press Ctrl-G to create the subsystem. The window now shows the subsystem and the 2 block destined to run on the host. Now, do the same for the remaining blocks. Select the 2 blocks and then generate a subsystem out of them. Move the 2 subsystems so that we could see the model more clearly. For clarity, rename the 2 subsystems to more representative names and then save the model. Select the DSP task subsystem and in the PARS window, click on the green button so that the PARS turns this into a DSP task. Then select the host subsystem, and this time we press the gray button representing the host tasks. Now click the yellow button in PARS so that it can do its magic and generate the entire application for the target hardware. You will see that PARS will call all the necessary software tools to generate the application, and the calls are seen in the MATLAB command window, and a progress window shows the work left to be done. Finally, PARS comes with the message that it has successfully generated the application. For each application, it generates a test bench so that we can now try it on real hardware. Run the host test bench. Because the application is running on the actual hardware, we need to change the simulation parameters slightly. Click on Simulation and then select Configuration Parameters. Change the variable steps to fixed steps and the solver to discrete. Press Apply and then OK. Press Play and then select the carrier card. In this case, there is only SMT310Q, and press OK.
The discrete Fourier transform of a real-valued signal is conjugate symmetric.
The application will load on the DSP and will execute. You should hear the same audio clip as before. Save the test bench so that all changes are saved for the next run. Next video shows the same application running on one DSP but with 4 tasks. Thank you. We appreciate your time.